Hello, viewers. In today's class, we are going to discuss a very important integral which can be solved by the application of beta and gamma functions, right? So, here we'll evaluate this integral that is 0 to 1 x raised to 4, and we have 1 minus square root of x raised to 5, right? So here to evaluate this integral, we'll make use of some important results from beta and gamma functions, right? So let us first write the results which are going to be used while solving this integral. So here first we'll take this integral as I, right? And we'll make use of the method of substitution. And the first important result that shall be used is the definition of beta function. That is beta m comma n is defined by the integral 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx, right? So this is the definition of beta function where m and n are greater than 0, and moreover this integral is known as Euler's integral of first kind, right? And the second result is the relation between beta and gamma functions, that is beta m comma n is equal to gamma m then gamma n divided by gamma of m plus n, right? And the third result is gamma of n plus 1 is equal to n factorial, where n is a positive, that is positive integer, right? So here let us take the substitution. So we'll take square root of x as equal to y, right? So that we have y square is equal to x. And see here the limits of integration are from 0 to 1. So when x is equal to 0, y is also equal to 0, that is square root of 0. Here we'll take x is equal to 0, so y is 0. And when x is 1, the upper limit, so y is square root of 1, that is equal to 1, right? Now let us here differentiate x with respect to y. So we have dx over dy is equal to 2y, that is equal to dx is equal to 2y dy, right? So now let us make all these substitution in this integral. So now I can be written as in terms of y. So we have the limits 0 to 1, x raised to 4, x is y square and raised to the power 4. Then we have 1 minus square root of x is y, and here the power is 5, and for dx we can now write 2y dy, right? So this is 0 to 1. This 2 can be taken outside the integral. Here we have 1, here we have 2 4s are 8, 8 plus 1 is 9, so we have y raised to 9, 1 minus y raised to 5, right? So now let us write this integral in this form. So what we will do, we can write 2, then we have 0 to 1, and y raised to 9. 9 can be written as 10 minus 1. And here we have 1 minus y raised to 5. 5 can be written as 6 minus 1. And here we have dy. So now this integral is exactly same as this one. That is, here we have the variable x, here we have the variable y, and since x and y are the dummy variables, so the dummy variable is not going to make any change here. So we have 2, and this integral is now the beta function, that is beta of 10 comma 6. The value of m is 10 and the value of n is 6. So now using the second result, we have here 2 beta of 10 comma 6 can be written as gamma 10. Then we have gamma 6 and gamma of m plus n 10 plus 6 is 16. Right? Now let us use the third result. Gamma of n plus 1 is equal to n factorial whenever n is a positive integer, right? So here gamma of 10 can be written as gamma of 9 plus 1, that is equal to 9 factorial, and similar is the case with 6 and 16, right? So we have 2 times 9 factorial, then we have 5 factorial. 6 can be written as 5 plus 1, so gamma of 5 plus 1 is 5 factorial, and gamma of 16 is 15 factorial, right? That is gamma of 15 plus 1 is equal to 15 factorial. So now let us calculate the value of this expression containing the factorials. So we have 2 and 9 factorial, and 5 factorial is 120, and now we can write 15 factorial as 15 times 14 times 13 times 12 times 11 times 10 times 9 factorial, right? So this 9 factorial and this 9 factorial get cancelled, and here we have 12 and here we have 10. 12 tens are 20, 120, so 120, and this 12 and this 10 get cancelled, and here we have 2 sevens are 14, right? So now the expression is 1. In the numerator we are left with 1, and in the denominator we have 15 times 7 times 13 times 11, right? So now we have to multiply these four numbers, and when we multiply these four numbers, we'll get here 1 over 15015, right? So the value of this integral is equal to 1 divided by 15015, that is 15,015. So this is how, by making use of the concept of beta and gamma functions, we can arrive at the desired result.